Hi students, this is next topic in hydrocarbons chapter, that is alkynes. Here the definition for alkynes is the hydrocarbons in which at least one triple bond. In alkenes at least one double bond. In alkanes all single bonds. Here the definition is what? At least one triple bond is present between two carbon atoms are called alkynes. These are also called unsaturated carbons. In alkynes, that triple bonded carbon undergoes sp hybridization. We know that this point very well. Next, the bond energy is more in alkynes than alkenes and alkenes. Bond energy means what? The energy is required to break the bond is called bond energy. In alkynes, 3 bonds are present. In alkenes, only 2. But in alkanes only 1. So in which case bond energy is more? In alkanes bond energy is more, because there we have to break 3 bonds. It needs more energy. So what is the point here? The bond energy of alkynes are more than alkenes and alkanes. Next, this is the order regarding bond energy. This is the order regarding bond energy. Next, to break CC bond, it needs 380 kilojoules. To break this double bond in alkenes, it needs 550 kilojoules. To break this bond, these 3 bonds in alkynes, it needs this much energy, that is 780 kilojoules. Next, these two are very, very important. Here in alkanes, only single bond is present. In alkenes, double bond is present between any 2 carbons. In alkynes, triple bond is present between any 2 carbons. What is the point here? Reactivity. That means if you break one bond, in alkenes or alkanes or alkynes, then automatically reactivity will be more. Now the question is, in which case we can break one bond, not all bonds, easily in alkenes? Because in alkenes pi bond is present. In alkynes also 2 pi bonds are present along with sigma bonds. In alkanes only sigma bond is present. We know that sigma bond is stronger than pi bonds. So we can break pi bond easily than sigma bond. But in alkanes 2 pi bonds are there. It is very difficult to break compared to 1 pi bond. So we can break pi bond easily. So what is the point here? In alkenes only 1 pi bond is present, so it can be broken easily, so the reactivity will be more. So alkenes are more reactive than alkynes. These are more reactive than alkenes. So what is the point? The reactivity of alkenes, enes are more than ines, are more than enes. Stability means reverse order. That means alkanes are more stable than alkynes. These are more stable than alkenes. I hope you understand. Next point. The simplest alkyne is C2H2. This is the simplest alkyne, nothing but first member of alkyne. That is what? C2H2. Next, if one of the hydrogen is replaced by methyl group in ethane, then next member of alkynes are formed, like in alkenes and alkanes. See, this is the first member of alkane, this is the next member, this is the next, like that. So from this we can write what is the general formula of alkanes is what? CnH2n minus 2. In case of alkanes, CnH2n plus 2. In case of alkenes, CnH2n. In case of alkynes, CnH2n minus 2. Next, alkynes are isomeric. This is important point. Alkynes are isomeric with alkadines and cycloalkenes. Alkynes are isomeric with alkadines and cycloalkenes. That means what? See, this is the molecular formula for this compound, as well as this compound. This is what alkyne, because triple bond is present. This is what alkadine, because two double bonds are present. This is what? Cycloalkene. This is cyclic compound. This is alkyne. This is alkadiene, but this is cycloalkene. So what is the point here? All are having same molecular formula, but their structures are different. So that what is the point? These three are isomers. So what are they? Alkynes, alkadines and cycloalkenes are isomers. This is very important point. In case of alkenes, they are isomeric with cycloalkanes, alkanes, but alkynes are isomeric with cycloalkenes, alkadines. Very important point. Next, in sp hybridization, the percentage of s character is more. Very correct. Due to that, the triple bonded carbon atom having more electronegative nature. The triple bonded carbon atom having more electronegative nature. So what? The hydrogens which are directly attached to sp carbon atom are called acidic hydrogens. In sp, percentage of s character is more compared to percentage of p. That means percentage of p character is less. If percentage of s character is more, size of the atom will be less. If the size of the atom will be less, if the size of the atom is less, then Vn will be more. So what is the point here? The hydrogens which are directly attached to sp carbon atom are acidic natures, because if acidic nature is if electronegativity is more, they gains electrons from hydrogen, then hydrogen readily loses as H plus, then acidic nature will be more. So that is why they are replaced as H plus. Replaced as H plus. Next, nomenclature of alkynes. What is this? Nomenclature of alkynes. See, HC triple bonds. This is first member of alkyne. What is its common name? Its common name is acetylene. IUPAC's name ethane. We know that. Here, three member alkyne. Its name is methylacetylene. That is common name. IUPAC's name propane. Next here, ethylacetylene. If hydrogen is replaced by methyl in acetylene, that is methylacetylene. If hydrogen is replaced by ethyl in acetylene, that is called ethylacetylene. But its IUPAC's name is what? Butane 1. What is it? Butane 1. Next, if these two hydrogens replaced by two methyl groups, that is called dimethylacetylene. What is it? Dimethylacetylene. Its name is, IUPAC's name is what? Butane 2 or cubutane. Next, if hydrogens are replaced by methyl and ethyl, then its name is what? Ethyl methyl acetylene. That is common name. IUPAC's name is what? Pentane 2 or 2-pentane. So this is about the nomenclature of alkynes. Now come to preparation methods of acetylene. What is it? Preparation methods of acetylene. There are two preparation methods. First preparation method is from calcium carbide. What is it? From calcium carbide. What is the point here? When calcium carbide reacts with water and then heated, then we get which one? Acetylene along with calcium hydroxide. So what is the point here? How to make acetylene, students? Whenever that calcium carbide reacts with water, then we get which one? Acetylene along with calcium hydroxide. Next, one more method. That is what? From vicinal halides. Vicinal means if two halogens present on adjacent carbon atoms. If two halogens present on adjacent carbon atoms, that is called what, students? Vicinal. That is called what? Vicinal. So what is the point here? When 1,2 dichloroethane reacts with alcoholic KOH. Alcoholic KOH acts as what, students? Eliminating reagent. Then what happens? See, I will show that reaction here. CH2Cl, H2Cl. When this compound reacts with alcoholic KOH, what happens? This HCl will be removed initially. That means this Cl will be removed from along with K. That means minus KCl, and this hydrogen will be removed along with OH, minus H2O. This is called dehydrohalation. That means we are removing hydrogen and halogen. Next, which will be left? CH here, Cl. double bond CH2. Or you can remove this Cl and H, that also will be right. Next, if it is reacts with one more alcoholic OH, then this Cl and this H will be removed. Then finally CH triple bond CH, because here single bond converts double bond converts triple bond after elimination. Here also same case, Cl and H2O will be removed. So like that we can make which one? Alkynes. See, alkynes. Here you can take NaNH2, NaNH2, that is also called soda, that is also called eliminating reagent, that is called sodamine. So you can take that one also here to make alkynes from vicinal halides. What is the, here one point is there, what is vicinal? Vicinal means if two halogens present on adjacent carbons, that is called what, students? Vicinal. That is called what, students? Vicinal. Next, these are the preparation methods of ethane. In alkenes we discussed preparation and properties of ethene. In alkenes we discussed preparation and properties of ethane. Here we discuss about preparation and properties of ethine, nothing but ethylene. Already we discussed preparation methods of ethylene. In next video we will discuss about chemical properties of ethine, nothing but ethylene.